Alright guys, so since the last set of vector questions were a little bit too simple, we have moved on to these ones. I have asked ChatGPT to give me some good and challenging practice questions for vector, so that I can like apply the functions of vector and learn it well enough. So this was the first question. In this we had to remove all the duplicates in the vector and keep the order of the elements unsorted, and it wanted us to, ChatGPT wanted us to solve this without the use of sets. So what I basically did is my first solution what I did is I just used a while loop with an integer I that remains less than the size of vector. In it I'm using the find function to find the next element, uh, which find the next occurrence of the current element, so the duplicate occurrence, using the find function from the next position. And if it is not equal to end, then I erase it, and in this case we do not update I. And if a duplicate is not found, then in that case we update I and move on to the next position. But this solution isn't the most efficient way of doing it. So ChatGPT gave me another solution, which was to remove all the elements at once. So there is a remove function in the algorithm library. So what we can do is, in the erase function we can just directly pass this remove function. We write the same thing as we write in find. We just give the starting iterator, ending iterator, and the target value. And after coming out of the remove function, we also have to add this vector dot end for the erase function basically. So this way we can remove all the elements from it that we might want to. Now we can move on to the next question. You can also try it if you want. Okay guys, so we have solved this question as well. In this we had to rotate the vector k times. Let me show you the question first. Yeah, so we just had to rotate the vector of integers to the right by k steps. So basically move everything to right by k steps, and anything that goes out of bounds will go back and get appended to the start. So what I did for this is I just after taking the input for everything, I checked if if value of k is greater than the size of the vector, because in case it is, then we might have to do loop multiple times and it can be a hassle. So what I did, I just took the modulus of k with the size of the vector. That will give us the remaining characters. Basically how many more basically what it will do is it will tell us if it's getting divided by that number, then in that case you have done a complete rotation of that main. Basically if k equals is a multiple, if vector of size is multiple of k, then in that case you will be rotating k steps, but it will be the same vector again, and otherwise you will just get the remainder of it, which is the number of times left to rotate it again after it has become the same vector for the last time. So then you after getting this value of k, you just create a vector result. In the vector result, you first add the last k elements of the vector, and after adding last k elements of the vector, you insert at the end of this result, you insert the first elements of the vector other than the last k elements. So basically vector dot begin to vector dot end minus k, and then you just print it all out. This was the simplest solution that I could think of. Let me ask ChatGPT if there is a more simpler solution for this. Okay, so ChatGPT has given us a very smart method. What it is doing is, instead of creating an extra vector of size n, which will result in like O of n space complexity, it is just doing in place rotation. So for that it is using the reverse function. What it is doing is it is first reversing the whole array. For let's take an example. Now let us take the first example of this. We have these 5 elements. If we reverse this whole array, it will become 5, 4, 3, 2, 1. So what we can do is in that 5, 4, 3, 2, 1, let me just show you. In that 5, 4, 3, 2, 1, what we can do is we can just reverse the first k steps. So 4 and 5 will be reversed, and then we can reverse the rest of the values in their place. So it will become 1, 2 and 3. So this will have rotated the vector accordingly. We can try implementing it as well. Very simple solution. In fact, let me just try it out. You can also try it out if you want to. Okay, so this solution works well, completely fine. Now we can move on to the next question. You can also try it out if you want to. Okay guys, so we have solved this question as well. In this we had to find the maximum contiguous sub-array. So basically any sub-array of this array that has the maximum sum, not any sub-array, the sub-array that has the maximum sum is the one that we have to return, not the sub-array itself, just the sum. So initially I thought that obviously the first solution that came to my mind was the brute force one, which is O of n square. You can just iterate once, then iterate for the elements ahead and keep summing to see which one is the highest one. It is one way to do it. Another was I searched for this cadence algorithm. I did not know what it was. So what it is you just keep a track of the maximum elements that you have until now and the maximum sum that you have had like the whole loop. So basically if I am on ith index, you just check what is the maximum sum till this ith index and the maximum sum of the array. So the maximum sum till ith index can be different and maximum sum of the whole array can be different. So how we did that is obviously you are going to be starting from the front. Another approach by the way I had is a two-pointer approach that could have also been used, but anyways we moved on with this one cadence algorithm. So what we can do is you can just take the first element and then start summing. If then you store the maximum that you get till now. So the first element, the maximum you get till now is -2. You just store it in this variable maximum till now and maximum sum accordingly. And then you move on to the next element. So for the next element, you check if adding the next element is if adding the next element makes the maximum till now greater or less than the previous one, and accordingly you update this new max till now variable. So basically what you are doing is for example you have moved until this index and you have got the maximum addition till here. So whatever the maximum addition till here, it only that you can use to either like increase it further by adding this element or maybe decrease it if you add this element. So if it is getting decreased by adding this element lesser than this element, it is becoming lesser than this element, then the maximum sum till now is going to be this element itself, because whatever you used previously is not going to be increasing it in any way. So for this case it will be only that, otherwise you just take the previous highest one and add accordingly. So for example we start with -2, then you go to 1, you check if -2 plus 1 is greater than 1 or not. If it is not, which it is not, then you just keep the maximum till now as 1, since just keeping this part, this sub array, this single one is the maximum that we can get till now, and you just update this variable maximum sum. Then you move on to the next variable as well. You just again do the same thing, you add 1 to it and you see if adding 1 to it is more beneficial or not, which in this case it is. You will get -2. So the maximum sub array till now is going to be this one, but the maximum sum till now is not going to be this one. It is going to be equal to 1, since the sum of this sub array is -2 and the sum of this single one is 1. So for contiguous arrays you can contiguous sub arrays you can do something like this. If it was a subsequence, the case would have been completely different and you would have had to solve it differently, but in this case it works fine. So yeah, I've tested out these test cases, these work completely fine. Let us ask ChatGPT if the solution is good or not. Okay, the only improvements that it has shown us is that basically error handling and starting from index 1, since you're already finding it from index 0. It doesn't matter, you can do it yourself if you want to. I'm just a bit lazy, so I'm not going to be doing that. Now we can move on to the next question. Okay, so we have solved fourth question as well. Initially, I misunderstood the question. So it was asking us to alternate between positives and negatives. And initially, I misunderstood it, and I thought that we had to find the negative of the same number, and then we have to alternate between them like that while maintaining the original order as much as possible. So what I was doing is I was trying to find the negative of each number. If it is present, then uh, I would accordingly I was finding negative of each number accordingly. If it was found, then I would erase uh, the negative number that was found, and then I would append it to its position accordingly and update I by 2. Otherwise, I would just update I just once and continue. And I had specified another case for 0, but obviously this was wrong approach because I misunderstood the question. Then I tried asking ChatGPT for some more test cases. Some of them failed. Then I asked it if I was doing it right. Then it explained the question to me well enough. So we just have to alternate between positives and negatives while maintaining the original order as much as possible. So obviously the simplest approach for this is to just use like two arrays, positives and negatives. So in order, add them to these both arrays, and in the end you just alternate between them and add accordingly. First positive, then negatives. First you add positive, then negative, and at the end, whichever vector is longer, you just append the remaining characters of the vector to this result vector that we have and just print out the result. So we can also like ask ChatGPT if this solution is efficient enough. Let me see if it is. Directly. Okay, I had made another mistake here. It had to be dot size. Now, since we did not have any test case to like check these conditions, obviously I wasn't able to see that there was a bug here. But when you're programming, you should like try to find test cases that uh, try to challenge all of your assumptions and all of the conditions that you have put in your code. Other than that, everything else is fine. So this works. Yeah. Now we can move on to the next question. You can also try it out with me if you want to. हाँ हेलो. कौन आकाश? हाँ वो तो पता ही है उसका तो. अश्विन भाई, अरे मैंने आपकी ऑडियो ऑफ कर रखी है अश्विन भाई, पर इससे पढ़ाई नहीं होगी. अब मैं अपना माइक ऑफ कर रहा हूँ. Okay guys, so we have completed this question as well, the fifth one. Very simple question. We were just given pair of integers. Using this a vector of pair of integers, and we just had to use a custom sort function to sort it. You can see these. In this we just had to sort it by the first element, and if those first elements were equal, then you just use the second element by the second element in descending order. So this should be opposite, by the way. If this is in descending order, then there is a condition that I can change is should be this. So what I've done for this question is that, of course, first of all, I'm inputting both of the values of the pair. I'm pushing it in the vector. Then I've created this custom comparator function. In this we pass two pairs, basically two elements of the vector, you can say. Two elements of the vector, and from these two elements what you can do is, if the first values of both the elements are not equal, then you can just check if the first value of the first element is less than first value of the second element. Otherwise you order them in descending order, sort them in descending order, like this. P1 dot second should be greater than P2 dot second. So what it does, it's basically the first element in the array should be less than the second element in the array. That is what it is doing. P1 is the first one, P2 is the second one. So that is the condition it is checking. And similarly in this case, but descending order with the second value. So then we just part it to this sort function and just print it out accordingly. I have checked using these test cases, it works fine. Now we can move on to the next question if you want to. You can also try it out if you want to. Okay guys, so we have solved this sixth question as well. In this, what we had to do is we had to uh, find the frequency of occurrence of each uh, unique number or unique element, and store that unique element along with its frequency, and then display the result in decreasing order of frequency, basically descending order. So what I did for this problem, since we were not allowed to use map, I decided to use a vector with pair. So that pair was, the first value of it was the unique element itself, and second was its frequency. Then what I did is I used a count function from STL to count the occurrences of that particular character. Then I pushed that character and the count of that character, basically the frequency, that character and the frequency of that character, to this frequency vector. And then I erased all occurrences of that character from my vector. So one problem that I was having in this is, in the remove function, I was directly passing vector of I. So what it means is it behaves weirdly, because each time since we are removing the element, vector of I keeps on changing, and it changes, since like after the first occurrence it would be like 1 1 and something like that. So basically, like if we remove 0, then the next position would be 1, then it would try removing 1 instead of 0 again in the array. So that was a problem that I was facing. I did not know that is how it worked. So I changed it. I just defined a target value, which is vector of I. Then I passed that target inside of it, and when I did that, it worked completely fine. It removed all occurrences of that particular character. For the while loop, I've used the condition I less than vector of size. You don't exactly need it. You can just say while vector size is greater than 0, and then just pass vector of 0 everywhere. But anyways, doesn't matter. Then I created this custom comparator for sorting, since we needed to show the result in descending order. So basically I passed two pairs in it, and I checked if the first pair second value is greater than the second pair second value or not, and then I just printed the result after sorting. So it seems to work completely fine. Let us ask ChatGPT if it thinks our solution is good enough or not. Okay. Okay, so ChatGPT thinks my solution is not the most efficient, which is understandable. It is an O of n square solution. Since count is O of n, erase remove will be O of n as well. So And then since we are iterating through the vector continuously, it will be O of n square. Uh, it told me that there is a more efficient solution that it is using, which is it is creating a vector of visited boolean vector of visited characters, and it's just putting it true if it has already been visited, and if it has been visited, it just continues. And it is inside of it, it is using a second for loop to iterate till the last position and to check if they have been visited or not. If yes, then it just continues. If no, then it uh, checks it with the rest of its occurrences, and then puts the rest of the occurrences equals to true, including the current one, and then increases the count along with it as well. Its time complexity is O of n square as well, but ChatGPT said that my is a little bit more inefficient because of large, like in cases of large inputs, it might not be that efficient, which is understandable, but at the end it is still O of n square. And since I'm practicing vector, I was trying to practice vector functions specifically, or functions related to it that I can maybe use later. So that works. Another approach it shows is using an unordered map. Like, come on, that is already uh, obviously it exists, but we were not allowed to use map, so avoid it. I mean, you can use it if you want to. To be honest, it's your choice. Since I'm practicing vector specifically, I adhered from using it, but it is your choice. If you want to use it, I won't stop you. And so, moving on to the next question. This was the sixth one that we completed. Moving on to the seventh one. You can solve it along with me if you want to. I will stay quiet now. So guys, I have solved problem number 7 as well. I kind of did it off camera because I had to go somewhere. But anyways, in the 7th question we had to print the 2D vector, basically the matrix, in spiral order. So this is a very common question for practicing vectors and matrices, basically 2D vectors. You must have seen it in a lot of places, including lead code. So currently solved it using the most generic and simple method. Initially, I did not want to do this. In this generic method, I have used another vector of the same size to keep a track of the elements that have already been visited. I kind of wanted to avoid that and use like a variable called steps and then decide how much I want to move and stuff, but it was getting a bit difficult. I wasn't able to really implement it correctly, so I just moved on with the generic implementation, the general implementation you can call it. So what I did for this is when we are traversing, let me show you using the test case for this. So yeah, when we are traversing, for example, since we are going in spiral order, first we will go 1, 2, then 3, then we will go 6, 9, then 8, 7, 4, 5. So you are going in spiral order in counterclockwise direction, you can say. So like this, here and there. So what I did in this case is I used 3 variables for direction. The first one is the dir variable. It just tells us whether we are currently going to be moving horizontally or vertically. And then there are 2 other variables. First is xdir, second is ydir. Both of these tell me if I should move in like the positive x direction or the negative x direction. And similarly, ydir tells me if I should move in the positive y direction or I should move in the negative y direction. Simple as that. Then there were 2 variables, basically the current row and current column, that we are going to be printing. I created another boolean vector of same size as the previous one, called visited. This is just to keep track of the indexes or the elements that we have already visited. By the way, in this problem I have just kept it n by n. Basically it will be a square matrix. You don't necessarily have to do that. In fact, in general you won't get that. For example, on lead code I don't remember it being a square matrix that you had to do the spiral traversal on. So you can just accordingly change that. I did not do it because I was feeling a bit lazy. I was more focused on the implementation rather than that. But anyways, so then I used another variable this is just to keep a track of how many times you are going to be iterating the loop. So the loop is going to be running n cross n times, basically the number of times, the total number of elements, basically. So what I did is, if direction equals 0, so basically we are going to be moving horizontally. Now that can either be positive x or minus x. Now the first condition that I check is if it is not out of bounds. If by any chance the current column, which is, since we are moving horizontally, we will have to change the current column index. So if it is out of bounds by any sense, then what we are going to do is we are just going to update the direction to move vertically. Update the direction of x to move in the opposite direction. For example, if currently we are moving in positive x direction, then we will update it to move in negative x direction later on, because we are moving counterclockwise. So we will once move positively, then move negatively for next time. And then we update the current row using the ydir variable, so moving on to the next position, and the current column with xdir. So xdir has become negative, and if we are out of bounds, then we want to come back one position. So this will automatically bring us back one position correctly. And otherwise, if that node has already been visited, I do the same things over here. So, and if it is neither of these cases, basically not out of bounds, and that specific element has not been visited yet. In that case, I'm going to be outputting that element and updating the visited variable, visited node, and update the current column, increase it by one position, positive or negative, it depends on xdir, and then I update I plus plus, because once we have printed a variable, that means one less variable that we have to print, and so we update I plus plus accordingly. Similarly, if direction is 1, then we repeat the same process, but in this case we will switch xdir with ydir, switch direction to 0, and switch current row and current column, since we will be iterating row wise now. Same, completely same logic, and yeah, this is it. I can also show you the output of this. If we have 2, 1, 2, 3, 4, the output should be 1, 2, 4, 3, completely fine. And now let us check with 3 elements as well. So 1, 2, 3, 4, 5, 6, 7, 8, 9. The output should be 1, 2, 3, 6, 9, 8, 7, 4, 5. 1, 2, 3, 6, 9, 8, 7, 4, 5. 1, 2, 3, 6, 9, 8, 7, 4, 5. So this works completely fine. I don't think it is the most efficient solution by any sense, but it works completely fine. So let us ask ChatGPT as well if this solution is efficient enough. By the way, another thing, I've used this vector visited. You don't necessarily have to use this. Another method to do this is to just update the values of this vector to like the an integer value which you will most probably not be seeing usually. For example, the maximum integer value or the minimum integer value. For that you can use c limits. You can include the header c limits and then use integer underscore max or min, update it with that instead of using this visited 2D vector or matrix. It will save you space. Instead of O of n square space complexity, it will become O of 1. Although GPT has said to me that there is another way of doing it. Instead of using the vector visited, we can just maintain a top, bottom, left, right bounds to avoid extra space. This is what I was trying to do with the steps, but it wasn't working properly. So, and also another thing, it showed me that I can combine these two conditions. I know these two conditions can easily be combined because whatever's happening inside of them is completely same. As I said, I was just feeling a bit lazy, so I did not do that, but doesn't matter in this case anyways. So one thing that I really liked is the way it handled the xdir and ydir, since I'm toggling it, like since I'm using two variables and multiplying it by -1 each time. Instead of it, what it is doing is it is updating the direction each time and just taking a modulus with 4. So we will get one of these indexes and it will be moving accordingly with these. So for example, if we are moving vertically in positive direction, we won't be moving horizontally. We moving vertically, we are moving horizontally once, we won't be moving vertically. Similarly with the cases of negative ones, since each one of them can also move in the negative direction. So this is quite smart, more readable, and more understandable. This I still have to figure out the space optimization, the way it is doing it, kind of. So you can try it out if you want to as well, or we can just move on to the next question. Okay, so this space optimized solution is very simple, very simple. What we are doing is basically we are doing the, for example, you might have solved like 2 pointers questions, so the starting index should always be less than the ending index. They are doing the same thing in this case. We are taking a top index. Basically, let me show you. So we are taking a top index for the first row, a bottom index for the last row, a left index for the leftmost column, and a right index for the rightmost column, and then accordingly we proceed. So what he's doing is, the bound check is simple. Top should be less than equals to bottom and left should be less than equal to right. And first he iterates the topmost layer, the first row, so updating the left variable. He's taken it in I, so updating it and moving towards the right. Then we move one row below, so we update the top variable to move downwards. And then similarly we take a variable I, put it equals to top, so we go from top to bottom, and we print out accordingly. Then we update right because now we will be moving one position left, and similarly we do with bottom, we do with left, and that is it. Very simple solution, definitely much better than mine, but it's fine. You can try applying this as well. Good solution. Now we can move on to the next question. So now we are going to be moving on to the next question, the 8th question. You can also try solving it with me if you want to. I will go quiet now. Alright guys, so we have solved problem number 8 as well. In the 8th question we had to find all the leaders in a vector. So according to the problem, a leader is an element which is strictly greater than all the elements to its right. Although it is saying strictly greater, it is greater than equal to considering one of the test cases. So I solved it according to the test case, but anyways. So for example, we can see that 16 is not greater than 17 to its right, but 17 is greater than all elements to its right. So 17 is a leader. 4 is not greater than 5 to its right, so it is not a leader. 3 again less than 5. 5 again, 5 is greater than 2, the only element to its right, so it is a leader. And then 2, since there is no element to its right, it is also a leader. So what I did in this case, I just kept a variable called max. So I iterate in opposite direction from the last element till the first element, and I keep updating the current maximum element that we have gotten. So uh, I initialize it with int underscore min, the most minimum integer value possible, and I create this vector result. Then I iterate in reverse, and if the current vector is greater than maximum, the maximum to its right, if it is greater than the most maximum element to its right, then it is a leader. In that case, I also update it as max, as the max variable, and I append to result, and then I just reverse the result. Although I don't know if you necessarily have to reverse it, but I did because in the output it is in the right order as the original array. So uh, yeah, and then I just outputted the result. So I've used greater than equal to in this case. Very simple question. Now we can move on to the next question. You can also try it out if you want to. By the way, in this question, in the 8th one, you don't necessarily have to push it at the back of the vector and then reverse it at the end. What you can do is you can also insert it at the front, so that way you won't have to reverse it every time. Let me show you that as well. Let us try it out as well if it works or not. Yeah, so this works. You can also do it this way if you want to. Now we can move on to the next question, 9th problem. You can also solve it if you want to. Okay, so we have solved this question as well. This was very simple. In this problem, we were given a vector of integers and we had to insert a value x at every even position. So, really simple question. I just took an input of both of these values, took an integer I equals 0, index basically, and I ran a while loop till I is less than the size of vector. And this condition is redundant, by the way. I don't actually need to check if modulus 2 is 0. So what I can do is I can just insert the value x at vector begin plus I, basically the current position, and then I update I by 2, I add 2 to it, so every time it will go into the next even position, and that is it. You can also run some test cases for this. For example, let us see. 4, 4. So we get the output 9, 1, 9, 2, 9, 3, 9, 4. 9 has been inserted to every even position. That is it. I have tested out all of these test cases. All of them work. You can also solve it if you want to. And now we can move on to the next question. I think it is the last one, 10th question here. So you can also try solving it along with me if you want to. And I will go quiet now. Okay, so we have solved the last question as well. This was way too simple. We just had to find the missing number in a sequence. Uh, for this, I just used the most simplest solution that's possible. Since I'm practicing vector, I just sorted this array and then I ran a loop to check which number is missing. That is it. Very simple. Another way of solving it could be to use the sum of first n numbers. Let me try doing that. Okay, so only in cases if the sequence is starting from 1. So if the sequence is starting from 1, then you can do this approach of the sum of first n numbers. You don't have to do anything, just find the maximum in the sequence, which is whatever it would be. You just find the numbers of all of these, find the sum of all of these elements, and you just find the sum of first n elements using the max value, and then you just subtract it from sum and return. So that is the simplest way to do it. But that approach only works if the sequence is starting from 1. Otherwise it wouldn't work, and you'll have to do edge case handling accordingly as well, like I had to do for if the vector size is 1 or 2, but whatever. Anyways, the previous solution is better. You should use that instead. Just a second. Because in that one you don't have to worry about the sequence starting from 1. It can be any sequence and you can just give the output for it. So with this, we have completed these sets of questions of vector as well. Some of the questions were really easy, and again, some of them really did not use our knowledge of vector, but uh, every single question was a learning experience in its own way. So you should try out all of these questions as well if you have not tried them out yet. And next time we will be practicing something else from the STL, or we can just straight up jump to DS as well. Although I would first prefer to complete STL itself and then jump to doing DS as well. So the solve-a-thons are going to continue, and have a good day.
So please whatever. Please I want to reach 1 million likes. So please sarapakara. Okay, thank you.